Each year, Microsoft Research hosts hundreds of influential speakers from around the world, including leading scientists, renowned experts in technology, book authors, and leading academics, and makes videos of these lectures freely available.
All right, good afternoon, everybody. Welcome to the last of the sessions that you'll have to choose from, the last of the parallel sessions. I think people are still wandering down the halls from lunch, but we're going to kick this thing off so we don't bunch it all up at the end here. My name is Alex Wade. I'm from the Microsoft External Research Team in Redmond, and our afternoon session today is Web Services for eScience, and our first presenter today is David Durour.
So I'll tell you about my experiment. When I did my brief video introduction, would you like me to wear that?
That'd be good.
That's really loud now for me. Is that okay for you? Cool. So the authors of the paper are myself, Carol Goebel, and Jitz. Carol, in fact, is the presenter of the next talk, so you'll get to meet her then. The title I will explain in one slide, and then I'll tell you about my experiment. So this choice of slide is partly, for those of you who've heard us talk before, a sort of iconic slide. It's used by a number of people in a number of different presentations, actually. It's used by our chemistry colleagues as well. And it really reminds us that science is a social process, and that we can start in the middle of this picture, perhaps with the chemists in the lab or the in silico scientists working with their workflow. They do some stuff, and a lot of eScience historically has tended to focus on the data deluge that then occurs and the computation that goes with that. And this is a picture that reminds us that actually it's a much more holistic process. There is a life cycle, there is a human workflow to all of this, and actually scientists do stuff, they produce all sorts of results, but traditionally these things come out in papers, they go through the scholarly communications process, the scholarly knowledge cycle, and they come back through, importantly, not just to inform the creation of new experiments in our labs or whatever our lab may be, whether it's the environment or the laboratory, or indeed the undergraduates are mentioned on here as well, because this is a very important part of our ecosystem of scientists. And that's how it's been for a long time. But in eScience, in this increasingly digital world that we're in, we have some new stuff coming out. We have the data itself, which we might want to link in to our publications. We have the metadata so that we can interpret stuff. We have the provenance so we can trust stuff. We have new things like workflows, which capture bits of method in machine processable ways. We have ontologies. We have all sorts of new things. And really, the space that this talk is in is this piece over here. This is where my experiment sits. And it says, actually, we could look at how to share those new things over on the left-hand side of the picture, and some people are doing that very successfully. But actually, in the Web 2 world of user-generated content and social collaboration tools, we can share that stuff and do stuff with it pretty effectively. And the next generation of scientists can do that. So perhaps that's where the acceleration occurs. Perhaps that's where we accelerate time to experiment. It's not processing the deluge of data faster, it's going around that loop faster. And then the interesting thing, of course, is to tie the right-hand side of the picture back to the left. So that explains the title. The rest of the talk has the simple structure. I'm going to tell you what this thing is, the experiment that is my experiment. And because this is an eScience audience, I'm going to tell you how we built it. And I think that will be of interest to some of you. And then really looking towards where it goes from here. So some of you will have heard us talk over the last year, maybe a year ago. Things have moved very fast with my experiment, and we're really now able to give talks where we talk about how people have actually been using the site, and we can also give a new vision for where things are moving on to. So starting with, what is it? So I'm going to focus on, out of those new artifacts, workflows. And that reflects one of the principles that we've used, which is to sort of focus on a specific type. It's also one of the Web 2 principles. Flickr does photos, YouTube does movies. My experiment started off by doing workflows. Now, workflows are really important and really useful, and they automate stuff, and they let scientists get on with doing science. But they're kind of tricky to build sometimes as well. So sharing them is useful because you can help your colleagues do things, but sharing them is useful because it helps you start creating your own workflows. It's a way of building the capacity to create new workflows. So that, you can see an immediate attraction to sharing these things. But there's more than that, because these are pieces of scientific method rather than just sort of pieces of data. Then we have this promise, this longer term promise, that maybe we can do new science as a result of sharing something from one area into another. This is our classic example, which some of you will have seen before, of Paul Fisher in Manchester, who was manually triaging a lot of data to do his work as a bioinformatician. And then he used a workflow to systematically process the data. And that way, you see one of the immediate advantages, which is that he was able to process a lot more. He wasn't doing the manual triage, and in fact, he found what he was looking for. He then bumped into Joe in the corridor. It's quite significantly in the corridor. I'll come back to that. And shared that workflow that he'd published in his paper in TRIPS, and without making any changes to the workflow other than to work in the area of mouse rather than cattle, Joe successfully completed some research that she'd been trying to do for 2 years. Okay. So you can see a real incentive here to sharing and the promise of the potential of new science coming out from this. So that kind of worked because Paul published his workflow, which is good, and because he shared it with Joe. Really what MyExperiment is about is that sharing piece, not just for two people who happen to work in the same institution and bump into each other in a corridor, but actually for the disconnected and decoupled community of users of these systems all over the planet. So in one slide, MyExperiment.org is this. Now, this slide used to say a year ago, Facebook for scientists. Actually, it said before that, it used to say MySpace for scientists. Now, we dropped MySpace because that became passé, we said Facebook for scientists. And now it says, no, it's not Facebook for scientists. And I'll come back to that. It's quite interesting as to how we've had to change that message. But it is the community social network. It is the way of sharing stuff for the reasons I've explained. Because it's for scientists, it provides very fine control, very precise control over the visibility of things. And that's one of the things that makes it different. We found immediately that scientists weren't prepared to use it unless we had that. Although there is one MyExperiment.org site, the software is available for people to download and use and create their own. So it isn't like one MySpace or one Facebook. It's actually something that you can have your own instance of. And it understands the scholarly knowledge cycle that we've already looked at. Interestingly, you can also run workflows on it, which takes it away from being just sort of a social network into something where you can actually do research. It becomes a virtual research environment. We started the project in March 2007, built a throwaway, what Carol calls, bubblegum and lollipop version, which we used to really get some, build up community attention and vibe and get our early user requirements in. And then we produced a version which went to closed beta in July 2007, went open basically a year ago. And now you can see the latest stats there. We're running with 1,300 members. They're the registered users of MyExperiment, but a lot more other users I'll come back to. And there's about over 500 workflows on there now. So you can all go away and try the site. You can play with it without creating an account, or you can create an account. And if you do so, you'll see some things which I think many of you will find familiar, if you're, especially if you're users of Web 2 sites and if you do things like shopping on the web. So there's a tabbed interface there. Currently we're looking at workflows. You can see the latest and last updated and most viewed and most downloaded workflows. There's Marco Rose with a Taverna workflow as the most viewed. If we did a search, here I searched for Trident, and we can see the results of a search. And here we've got a number of Trident workflows. Trident's the Microsoft workflow system that was presented in a tutorial on Sunday by Roger Barget. If we drill down and actually view one of the workflows, you see some of the things that the site's bringing that makes this different. So a lot of other workflow systems might make workflows available by putting them in a repository on a web page. What's different here is we have things to encourage and facilitate the sharing, and we understand something about how scientists share and why they share. So what you see here is what we call the social metadata. You see we have the license, we have credits. So this particular workflow is based on one by Paul Fisher, but it's then been, this version is by CEDA. We have attributions. You can see the usual tagging that you'll be familiar with there, and there are revisions and so on. So that's what an individual shared artifact on MyExperiment looks like in terms of the social metadata. And the content's been building up. As you can see, we've got over 500 workflows. There's Taverna, there's Trident, there useful chem. There's a sort of variety of new things appearing on there now. The community is building up as well. So the number of users, there's 1,300 registered users, the number of groups they form. So they form their friendships and they form groups. They use groups in different ways. Some users create some data, build a group around it. Some users create a group to go with their project and have members and share data within that, and so on. It's quite interesting to see the different kinds of sharing behavior in different communities. Now, social science colleagues who are working with us on the project are using it as an instrument to observe exactly that scientific practice. So the homepage gives you a feeling for the current state of things. So it's 1,300 users, 536 workflows, 40 packs. I'll come back to packs. And every time we log in, we see the latest stuff that's gone up there. And you just see a few of the workflows that have been uploaded recently and see the areas that they're in. And some of you in the room may even have put them up. So that gives you a feel for the site, and I really encourage you to go away and try it out for yourself. And I think what I've tried to highlight there is what we call the social metadata, and that we have the growing content and the growing social network. If you look at the Google Analytics for the site, you see a different picture, because these are the people who access the public content without being members of the site. And what you see here, if you stare at the thing at the bottom, is about 500 unique IPs, new unique IPs every week. And you can see we have an international set of accesses. If any of you in the room are from Brazil or perhaps you're the person in New Zealand, I probably do have a MyExperiment sticker for you. Actually, we do. We really do have MyExperiment stickers and mugs. So don't go away without a sticker. Let's go back to that, what is it thing? 'Cause is this a social website? Is this a virtual research environment? What's that about? Well, we dropped the MySpace thing because it's actually putting people off. Scientists didn't want to use things like that because they see things like that as really just public sites where stuff is shared. And we're not like that. We actually have a lot of control over privacy. You can have your own instance of MyExperiment and so on. So let's just have a look at some of the differences. Those are the sort of features which you will find when you go through the site. And the first set are the things that perhaps you would find on Flickr or Facebook or anywhere else, including the developer interface, which I'll come back to later. These things down the bottom are the ones I think that make us stand out and show that we've really worked very, very closely with scientists to build this site. And it is the credits and attributions. You've seen a glimpse of that. It is the fine control over sharing. It's these things called packs. It's the federation and inward. So I'm just going to drill down on a couple of those. Ownership and attribution. It took us a long time to get this exactly right with lots of focus groups and mock-ups. But when you actually upload something, in this case a workflow, you can expand these tags, credit and attribution, sharing and licensing, and you get a number of options which are what people have asked for. So if I just have a little look at sharing, for example, specifying whether the thing you're uploading is being shared with which of your groups and what they can do with it, and so on. So that's a very simple interface for what's actually a very sophisticated sort of policy model underneath. Packs are really interesting because, having said we're Web 2, we start by having our own data type. Data is the next Intel inside, as they say in the Web 2 slogans. Like Flickr has photos. Well, we started with workflows, and that's the right thing to do. But actually, scientists don't work with individual types of digital content. They work with collections of stuff. All the pieces you use in your experiment form one bundle of stuff. All the pieces you use to make a clinical decision form one bundle of evidence that you want to save and come back to later. So we introduced this notion of packs, and from the user interface viewpoint, it's very much like shopping or building a wish list as you move around the site. You can collect stuff together. So for example, you could take a workflow and the files that were the input and output files for that. You could create example files for people to reuse the workflow. You could capture the actual data you use in your experiment. You might want to form a pack of 10 different workflows you're using for a tutorial. We have packs of all Carol's keynote slides, for example. So you can form packs of anything. It's interesting that the things in the packs don't just have to be things inside my experiment. We can point at anything. We have external links as well. Fewer guarantees about what happens if you're pointing externally. And then those packs become entities just like the other workflows that you've seen here, and they can be tagged and shared and discovered and discussed easily on MyExperiment. So there's a pack. This is a pack of Trident workflows, for example. And sort of a hook into some of the other things that have been discussed at the conference. A pack is really a bundle of URLs, okay? And the way we've chosen to communicate these with the rest of the world is to use the ORE, Object Reuse and Exchange representation. Was it this room or the one next to it yesterday? We had a talk from Carl and Simeon about exactly this, using exactly that picture. So what this says is that you can collect a number of entities together in an aggregation, and that aggregation can be described by some sort of resource map. And we've used exactly that model for the packs in MyExperiment. So that's really a hook into other things in the conference. So that gives you a feel for what it is. You can, if you're a user of a workflow system, you could go to MyExperiment to find some workflows, just discover them, use them. You could use it then to upload some of your own and share them. The ratio of sort of producers to consumers is something we're monitoring. And at the moment, there are a lot more consumers than producers, and some very prolific producers. It will be interesting to see how that pans out. I want to focus now more on the developer side of things for the people in the room who build these systems. So I'll tell you a little bit about actually how we built it, but also some of the principles we've used. This picture was drawn at least a year ago by Savas, who introduced Paul, who's over there for the keynote at the beginning of yesterday. And Savas has been looking after us from a Microsoft viewpoint in this project. It's quite an interesting picture, because when you first glance at it, you expect to see MyExperiment in the middle and loads of interfaces to access it and loads of stuff behind it. But that isn't what it is. If you look more carefully, MyExperiment is just one of the things in the back end there, in the cloud. It's just something which provides some services that anyone can mash up over, basically. So that's the Web 2 piece there that's very important. We don't reinvent anything else. We reuse other stuff as much as possible, and we make all our functionality available for other people to reuse as much as possible. So what you've seen so far has been an HTML interface to a website. This is actually designed to have any form of interface you want to build. So for the developers in the room, with a very quick build of the PowerPoint, I'll just give you a quick glimpse about the entities in the system that is MyExperiment. So there's a Ruby on Rails code base which captures all the stuff you can see in the box. And as those of you who are familiar with Ruby on Rails will know, we have a number of instances of this running under a mongrel cluster. They all talk to a MySQL database where all our state is stored. Those are the things we decided were inside the box. I mean, we want to reuse things outside as much as possible, but our value proposition as MyExperiment is the social network and the workflows, and that's therefore what we have inside the box. And if you talk to it with HTML, you get the interface that you've seen. However, the content can be elsewhere. We could be talking to DSpace or ePrints, SRB. I don't know where that A came from. I'll have to remove that later. And anything else out on the web. So, for example, the packs pointing out at other things, but also sort of virtual content where when we import some content from somewhere else, we can put in the metadata as well using things like the OAI harvesting protocol. Then there's the search engine, which is a separate box. Okay, that's significant, and we can have one search engine running over multiple instances, and you can access that directly. And we have the enactor, which actually runs workflows, but that's a separate box. And again, when you build your mashups, you could talk directly to that, or you could talk to MyExperiment. Significantly, even though the API to this was technically a REST API anyway through Ruby, we have what we call the Managed REST API, where we've done an awful lot of work to, as much work on this, I would say, as we have on the user interface, to build the API that developers really need to build stuff quickly. And that's managed by actually being completely soft configurable. So we actually put in an Excel spreadsheet which contains our API description, and we plug it in there, and that's how the API is built and how the API documentation is built. That's been a very effective way of building it. It's hard work to set up, but it's really paid off. So we have all sorts of users building various things over it, as you can see, through Facebook, Google, Android. I'll show you a couple in a minute. We export representations like ORE, as I've mentioned, and FOF and SHOC, which I'll come back to, and most recently, this tail on this strange animal. We have a triple store, and we have the content in the data model of MyExperiment in Ruby being exported with the MyExperiment ontology and then a Sparkle endpoint, so you can query that directly with Sparkle. So for developers, all those interfaces are simple, RESTful interfaces. The point is you can bring the MyExperiment functionality into the environment of the researcher rather than forcing the researcher to come to MyExperiment. Okay? And you can use those interfaces. That's one way of working over the system. But equally, you can download the software and do what you want to with it. If anyone's more interested to find out about this, then wiki.myexperiment.org is where everything's kept. So the sort of interfaces that people have built are Google gadgets via Google users. So some of those workflow functionalities, like seeing the latest workflows, playing with the tag cloud there, and doing a search, coming through AI Google. If you're a Taverna user, for example, using the Taverna workflow workbench, then you have a Taverna plugin for MyExperiment, so you can access the functionality from within the Taverna environment. If you're a Facebook user, you can access the MyExperiment search. Okay? I haven't got an example of it because I sort of need a physical one. We have an Android interface as well for mobile users. There's a Silverlight interface building a rather dynamic session-oriented interface over the top of the functionality that's there. So this gives you an example of some of the things people are doing. There's a query to the Sparkle endpoint. So for those of you who speak Sparkle, you'll see that all that XML there, well, not XML, all that text there, is what you need to express a query. Say, give me all the accepted friendships, including the time at which they were accepted. And if anyone's interested in, anyone doing research in the semantic web area is interested in using this interface, then that's available really as a research support. This thing is interesting, SHOC. It's pronounced SHOC. It's written semantically interlinked online communities. And that's the ontology we're using to export and share information about the social network. And as you can see, we have some other familiar things in there like FOF and Dublin Core and so on. So this is actually working quite well in that respect as well. And the way we built it, well, there's some principles. We built Taverna, learned a lot from having Taverna adopted by lots of users, and then applied those principles to something else, which is MyExperiment. Taverna is a piece of software going through a software engineering process and being installed on machines. MyExperiment is a website which people access through a web browser. And it's quite interesting to take that set of principles established through one and put it into the other. And we've written a paper about it. And this paper is coming out in the next issue of IEEE Software. So I thoroughly recommend that to you, where you can read about these principles. So our 6 principles of software design, and you'll have seen some of these already in what I presented. Fit in, don't force change. So that's taking the functionality to the working environment of the scientist. Jam today, more jam tomorrow. That's the workflows that give you the automation, but there's potential for greater reuse. Just in time, just enough is the perpetual beta that is MyExperiment. At local, think local, global. We're focused on specific workflow systems and specific communities like bioinformatics, chemistry, music, social science, rather than coming up with generic solutions for everyone and then wondering why they're not using them. And then we're now getting to the point, because the social network's grown and the content's grown, that we're beginning to see the network effects. So it's now more difficult to find stuff because there's more of it, but in principle easier to find stuff because we can get more recommendations through the usage of it. And that's exactly where we are in the project now, trying to balance and tension those two pieces. People uploading the content, like the workflows, are adding the value, but so are the people adding the reviews, doing the favoriting, etc., etc. Anyway, I recommend the article. So finally, to show you where our thinking is going, having got to this point, the site's there, it's been running for a year, increasing number of users, stickers, mugs available, growing over, new communities, new kinds of things being shared. What we observe in looking at how eScientists and how researchers are working and using tools like MyExperiment is this kind of life cycle. There's the discovery piece where they're discovering their workflows or their data sets or their models. They do something to acquire that, to get the rights or to actually get their hands on the actual content there. Do some stuff with it to make it usable. And then they do the research, which involves mapping and transformation. It might involve some computation. It might involve integration of data from other sources and so on. So interpretation of that, and then somehow that goes back out for dissemination under whatever sharing model or whatever scholarly communications model, but ultimately also the curation challenge. So this is a fairly generic picture. We see this across a whole lot of domains. Very interestingly, in Peter's keynote this morning, in humanities, it's the same picture. It doesn't matter that it's humanities as opposed to, I don't know, shared genomics or obesity or whatever else that is we're applying these in. And there's some cross-cutting things there, of course. Provenance important all the way through, so we can reuse and interpret the results, so we can trust them. Security access critical, especially for working in particular domains. Getting the identity and naming right, something which is taxing a lot of people at the moment. So that's a sort of a picture of what we see as the human workflow, if you like, and it's like a different take on that initial picture of the social process of science. This is what the individual researcher is going through. We want to support that. We want to create the laboratory for that out of a set of components which, where the utility of any one of those components probably can transcend the application it was originally designed for. What we're looking for is a set of pieces where we can assemble these laboratories for particular users. So, for example, if you look at what we've got in MyExperiment and you look at how people are using it and what they're using it with, for example, Taverna, you start seeing a set of services that are actually common to e-laboratories. This isn't a comprehensive list, these are examples. If you look at other projects which are related to MyExperiment and fit into this e-laboratory space, then, for example, Biocatalog, which Carol's about to talk to next, so this slide is a hook for Carol. Biocatalog is bringing this annotation piece and monitoring and the social curation piece into the world of actually cataloguing the web services. So you can see how some of these ideas map across, but you can then see something else, which is how Biocatalog itself fits in with MyExperiment, because it means people that were using the MyExperiment interface can now find out something about the services that are being used in the workflows, which are the reliable ones, which are the recommended ones, which are the ones that are always available, which ones are never available, and so on. So you can see now a component being built which brings functionality back into MyExperiment. And how do you seed Biocatalog with services in the first place? Well, you go to MyExperiment and you go through the workflows and you extract them. Okay? So we're beginning to get this symbiosis between the different components. I hope this gives a glimpse of our thinking at this moment in time. And what we think is the correct glue to hold all this together. We don't think we can come up with a definitive and complicated Uber architecture for the laboratory. We think the glue is actually going back to where we started and being data-centric and understanding what those research objects are that are being exchanged by the components of these systems. So the packs that we've seen in MyExperiment and the workflows themselves are examples of research objects. What we anticipate is some sort of shell around these things which is widely understood, so that we can transport and share and tag and work with these entities as you do the packs in MyExperiment. What's inside them will vary on a domain-specific way. And that's where we are now in our thinking. We just had a workshop a couple of weeks ago to begin to define these things. And I think that's how this will map into, there'll be people in the room working in different domains. The question I'd like to leave you with is, what are your research objects? What are the shareable pieces? What are the things you could share in something like MyExperiment? And we'd love to know, because we're trying to build systems that are going to handle that variety of SROs. So to close, I'll just reflect on a sort of year of MyExperiment. We provided social infrastructure. It's infrastructure, but we understand the social piece. We understand that sharing and science and the social process is a social technical piece. And we understand that scientists collaborate in order to compete. They may or may not be the same as teenagers. We'll let our social scientists decide on that. And where we are now is that the community is growing and the content's growing, and we're dealing with the interesting opportunities and tensions that result from that. We're supporting Taverna and Trident and UsefulChem and other workflows. In the pipeline, we're working with Kepler, we're working with Meander. There's a workflows workshop tomorrow where you can hear about some of these things. The scale at the moment is making it more difficult to find things, and should also be making it easier. We're just trying to get that balance right now. We could share all sorts of other stuff, okay? If you want to share other things like statistical models, like R scripts, like MATLAB, whatever, then we're very interested in working with people to build versions of MyExperiment that do that. And we have this vision of this SRO that you can pass around that contains all those different pieces, and you can execute them, and the research process is evolving within the SRO, and it could be the bits of it defined in workflows, bits of it defined in scripts, whatever. That's the thinking there. We're targeting where we believe research will be conducted in the future. The words open science were in the title for that reason. The panel yesterday was very interesting, with people talking about how do you improve time to discovery, and Jeremy Frey in particular, I think, presented a vision, and I think then Tony Hay asked the question of, can you really people really prepared just to put all their data straight out on a blog? Well, good question, lots of issues around there. Some people believe absolutely yes, some people believe definitely no. But that world of open notebook science is the world of assembling these individual pieces to do new science in new ways. Okay, with that I'll finish. Thank you very much.
Great, thank you very much, David. We do have a couple minutes for one or two questions, and Carol, I'll ask you once you come out, get your slides ready. Questions?
I think this is a good initial concept, but as a scientist myself, and I constantly doubt whether other people's experiments are trustworthy, and I only use the experiments that are published from other journals and to improve upon. So could you comment on what you're doing specifically there to ensure that we can do not only everyday popular science, but the high-quality science on your platform?
It's interesting that's the first question. When I gave a keynote to this at the IEEE eScience conference last December in Bangalore, and that was the first question then as well. And I transcribed it onto my slides. I haven't used those slides today, but I have a slide with under the heading of myths, and one of them says, "You're letting the yoiks in." And unfortunately, that phrase doesn't translate very well, and I haven't found a better way of putting it. But the Brits in the room will know what I mean. So this is the concern that democratization reduces quality and damages the elitism that's necessary to promote good science. So there's a lot of well-rehearsed answers to that, philosophically, i.e. the peer review process that we go through already in science is equally valid here. But you have more peers, and more opportunity to do that sort of thing to improve quality. You also have provenance. You have the fact that you're working in a digital domain to enable you to use new techniques in order to make guarantees about things. You're getting the network effects and the benefits of scale, so you know a lot more about exactly how people are using stuff on which to base recommendations automatically, and you've got explicit recommendations as well. So there's a whole set of stuff, but we don't know. The experiment that is my experiment is to find out some of those things. And that's why we have social scientists working with us who are interested to see, do scientists share enough to get the benefits of these effects? Is democratization a problem? It probably depends which domain you're in. I've had very different reactions from different communities to that question. So we believe the pieces are there, and we're watching, we've compiled and pressed go, and we're watching what happens now. And we'll do some other things along the way. To explore those issues. So it's a good question.
Paul?
Thanks. So I've got a geeky question. So you've got this quite sophisticated security model so that people can choose what to share and what not to share and who to share it with and so on. And now you've got this developers API and a Sparkle interface. So was it a problem overlaying that security infrastructure through those?
So the managed API, the XML API, which is the REST API you'll see routinely, uses OAuth, and we've used that successfully for things like the Facebook app. The publicly available Sparkle endpoint only has public content behind it. So there's a filter. If you look at the picture, it's interesting that the Sparkle endpoint boxed is actually an arrow going straight into the middle of the code base rather than through the API, because there's a filter in there for exactly that reason. If you're within the project, then you can get at the other content, which is appropriate for the usual things of building monitoring the performance of the system and backing it up and all those things, but anyone outside absolutely can't get at anything. We haven't solved, we'd like to know the answers to some of the issues around that. I think that's a space we have to go into the future as well. Yeah. But yeah, security over RDS triple store queries isn't a solved problem.
Okay, great. I think we do need to move on to our next presentation, so join me again in thanking David Deror.